Greetings, math fans. All right, I'm going to do one example of something called logarithmic differentiation. Okay, so logarithmic differentiation. Okay, we've done this already the previous day where you had x to the x power, and you had to do it. You were forced to do it because there's no other way to do it to take the derivative, right? Because you got to deal with a variable both in the exponent and in the base. Well, now you actually have a choice what to do, but it just goes a lot smoother. So here's your example. It's y is equal to the square root of x times x squared minus 1 over the square root of 2x minus 3. Okay, so this is your problem. Now that looks really nasty because you could do the product rule and the quotient rule, but you have to do the product rule, quotient rule, you have to do chain rule. This is actually kind of a nasty problem. What you could do is we can actually take the log of both sides. So and we're going to do the natural log, of course, of both sides. So we're going to get ln of y equals ln of, and we're going to do square root of x. Okay, now what can you do with this? All right, well, again, I haven't even started taking the derivative yet. I'm just trying to simplify this. Do you guys agree I can do properties of logs here? So basically I have product, and quotient, right? Product of that, and then quotient. So what I can do is, if I write ln, I'm going to write this way, just because we're going to simplify it later here. So ln of x to the 1/2 power plus ln of x squared minus 1 minus ln of 2x minus 3 to the 1/2 power. Okay, and again, I'm going to still simplify it, so it's 1/2 ln of x plus ln of x squared minus 1. Please, this is a huge mistake that people make. Please do not write this as ln of x squared minus ln of 1. That is a huge mistake. That is not a property of logs. Do not do that, because what you're doing is you're doing addition subtraction. You're saying, oh, I can rewrite that as addition subtraction. If that was ln of x squared times, let's say, or x squared times, I don't know, the square root of x. That's multiplication. Then I can write as addition, ln of x squared plus ln of radical x. But otherwise, you cannot rewrite that. So you're going to leave it the way it is, and then minus 1/2 ln of 2x minus 3. Okay. Now I can apply my properties of logs, so I get 1 over y dy dx. Okay, I'm going to run out of a little room, so I'm just going to keep cursoring down here. 1 over y dy dx is equal to 1 over 2x, right? Derivative of x, ln of x is 1 over x, plus 2x over x squared minus 1, right? Because x squared minus 1, then the chain rule, derivative of x squared is 2x, so that's why I get the 2x on top. Okay, so then it's minus 1/2, and that's going to be 1 over 2x minus 3. And the chain rule, again, the derivative of 2x is 2. So we're going to do 2 here. So just to kind of simplify a little bit there, that cancels out. So we actually get minus 1 over 2x minus 3. Okay? So I want to write that out a little cleaner here. Okay? Now, this is the deal, math fans. You could be almost done. All right? And if you multiply both sides by y and then substitute that in, you could be almost done. I'm trying to show you a little bit of cleaning it up with just algebra, with basic arithmetic, simplifying fractions. And the reason I'm trying to show you that is because if it's a multiple choice exam on the AP exam and they ask you which one is this equivalent to or what's the answer, you actually have to go further than just this. All right, and so what I'm going to do is I'm going to get a common denominator, and my LCD is 2x, x squared minus 1, 2x minus 3. Do you agree with that? So I'm going to multiply. I get 1 over y dy dx. And like if I basically need to get that 1 over 2x, I need to multiply that by x squared minus 1 times 2x minus 3. So I am going to, well, first of all, let's do this. This is my denominator. So if I multiply the 1 over 2x by that over that, I wind up just getting x squared minus 1, 2x minus 3. Okay, the next one has x squared minus 1, so I'm going to have plus 2x times the new 2x times 2x minus 3. And the next one's got a 2x minus 3, so it's minus 2x x squared minus 1. Okay, little messy, but we're going to keep going here. And if I FOIL this out, I get 2x cubed minus 3x squared minus 2x plus 3 plus 8x cubed minus 12x squared minus 2x cubed plus 2x. Okay, kind of brutal, but got all my terms, I think. All over 2x, x squared minus 1, 2x minus 3. Alright, so combine like terms, I get 1 over y, dy dx. And actually goes nicely. We have 8x cubed minus 15x squared plus 3 all over 2x, x squared minus 1, 2x minus 3. Okay, so I simplify the top as much as I can. Now all I'm going to do is I'm going to multiply both sides by y. So I'm going to get dy dx equals y times please don't leave it like that. You guys should know better. Our original value of y was, well, you can look at it. It's the square root of x times x squared minus 1 over the square root of 2x minus 3. So I'm going to get dy dx is equal to the square root of x times x squared minus 1 over the square root of 2x minus 3, and then multiply that by 8x cubed minus 15x squared plus 3 all over 2x x squared minus 1 and 2x minus 3. Now the reason I did all this, math fans, is because of this. A few things I can kind of deal with. Okay, first of all, let me highlight a few things here. Right, this guy and this guy, I can simplify that. And I have an x squared minus 1. And do you guys agree the x squared minus 1, what can I do with that? Right? Do you guys agree the x squared minus 1 and the x squared minus 1 is here? Okay, so I can cancel that out. And then I have this and this, which I can actually combine together, right? So let's put it all together. I have 8x cubed minus 15x squared. Nothing I can really do with that. Plus 3 all over. I have the square root of x and 2x there, so I can do 2 square root of x. You guys agree with that? That takes care of that part. X squared minus 1's cancel, and I have 2x minus 3 and the square root of 2x minus 3, so I have 2x minus 3 to the 3 halves power. Okay, and that is my answer. Looks a little nasty, okay, but the whole point of me actually simplifying and then multiplying by the y is when I, with the y, right, all this stuff happened. There's a lot of stuff that happened here. Okay, things that canceled out with that denominator, and then I get my final answer. Okay, so again, I'm going to write even right here. This is ugly to simplify. Okay, but it might be a multiple choice question on the AP exam. And if it is, then you better be able to know how to simplify it using all your just algebra knowledge. All right? That's it, math fans. I hope you guys learned a little bit about logarithmic differentiation. Probably won't all be this nasty, but you need to know what you're doing. All right? Adios, math fans. Goodbye.